single day of teaching this year. All right, so the first thing we want to talk about in these little word problems is what we call an angle. And then we all know what angles are, and this is an angle of elevation. So if we understand, if you elevate, you move up. All right, so an angle of elevation is the angle formed with the horizontal as an observer. So focus on this word right here. If I look at this triangle, isn't this here the horizontal side of that triangle? That is as your observer, which we're going to see here a lot of times as a person, looks upward at an object. So if this is our horizontal and we are here looking upwards at an object, so this is us looking upwards, then the angle of elevation is this angle right there, the angle that we look up at. Okay? You then have your right angle. We have to have that anyway to do any of the sine, cosine, tangent stuff or the Pythagorean theorem. This is all specifically right triangle trigonometry that we're working on. So that's going to be this. This is not your angle of elevation. That's the angle you kind of look down at, right? We're not looking up anymore. All right, so same here. Our angle of elevation for this one is this guy right here. This is your horizontal. Your bird would be up in the air. We are looking up at the bird, so this is your angle of elevation. When we talk about an angle of depression, that is the angle formed with the horizontal as the observer looks downwards. So now if we're looking downwards, think of this as kind of a building. A lot of these questions we're going to work on here in a minute. We're going to talk about a building. So now let's pretend we're standing on top of the building. Here's the horizontal for the person who's standing there. And then it's the angle that we look downwards. So if this is a boat, I'll draw a beautiful boat down here. So if that's our boat and this kid's looking down at the boat, here's the horizontal. Here is the line of sight for this kid. The angle formed by the horizontal and his line of sight is this angle right there. Now, what's going to happen a lot though with these? Because if this is the triangle, right? Recall something, that if this is a horizontal line, isn't this also a horizontal line? That means these are parallel. And then isn't this angle here, and then an angle that's actually inside of our triangle, those are alternate interior angles, correct? We think back to that. And alternate interior angles are congruent. So whatever your angle of depression is, so let's say this ended up being a 30 degree angle, this would also then, we would know, be a 30 degree angle. All right, so we need to know those two things. If we can keep that straight, these problems are really pretty nice, and it's the same exact stuff that we just got done doing the last couple of days of notes. All right, so with that thought in mind, number one, you're going to want to draw a little picture. Hopefully you're a better artist than me, and don't judge me. It says the angle of elevation from a point 49 meters from the base of a flagpole to the top of the flagpole is 27 degrees. We want to find the height of the flagpole. All right, so flagpole, I can't mess that up. I'm just going to draw it as a straight line. So that's our flagpole. Then we have a point that is 49 meters, bless you, from the base of the flagpole. So take a point, we'll put it over here, and that point is 49 meters away from the base of the flagpole. Then eventually now let's circle back to when it says the angle of elevation from this point. So from this point right here, the angle of elevation to the top of the flagpole. So from here to here. So if we are at the bottom, we're looking up to the top. That angle from the horizontal to the angle that we are looking up with is a 27 degree angle. Question then, find the height of the flagpole. So since this was our flagpole, this is what we're looking for. That's what we don't know. That's what we're going to call X. And now we've been doing it for a good 3 or 4 class periods. So SOHCAHTOA, you now need to determine which one of those applies to this problem. So if this is our reference angle, we now need to identify what are these two sides. are those two sides the opposite, the adjacent, or the hypotenuse? And depending on which they are, we then pick which option. All right, what do you think, Cam? Good. Cam says tangent. That is correct. So we're going to say the tangent of that 27-degree angle equaled, and the reason he picked tangent is because what was the opposite side, Cam? Good. The opposite side was the x over, and then what is the adjacent side? Yeah, that 49. Now, this is a nice one to solve. This is one that I think everybody would solve correctly. There's no second function. We don't have to worry about the inverse, the weird little tangent to a -1. We want to solve for x, so we need to get rid of that 49. We would do that through multiplication. This should be easy to plug into your calculator. Just make it look like this. You have a tangent key in the calculator. You just type in 49, tangent of 27, like so. And as long as you are in degrees, if you're typing this in and you're still not getting it, now's the time to let me know. We should get that. And then what do I tell you to round to here? All right, to the nearest 100th. So that would mean this 6 should get bumped up one spot since the number behind it is greater than 5. So 24.97. And then these, we're looking to see how tall it is. So we want to give it a unit. So we know it's not inches or feet. In this case, it is meters. So we're about 25 meters tall. That's how tall the flagpole is. All right. So it's really the same stuff we've been doing. You just got to draw the picture and assign the variables and the numbers at the appropriate spot. All right. 15. A 15-foot ladder is leaning against a house. So here's my really bad house. And then we have a 15-foot ladder that's leaning against it. Then that ladder, so the 15-foot ladder, I've got that drawn in. It's leaning against the house. We've shown that. It is making a 52-degree angle with the ground. So our ground, here's our ground. And then you were told that this is a 52-degree angle. The question then, how far will the top of the ladder, so this is the top of the ladder, be above the ground? So if this is the top of the ladder, aren't we looking for this length right here? How far above the ground is this going to be? So we're looking for this. That then means that's our variable. With this as your reference angle, look and see, what does x represent? The opposite, the adjacent, or the hypotenuse. What does 15 represent? Opposite, adjacent, or hypotenuse. And then based upon that, you are picking from our three options from the SOHCAHTOA stuff. All right. All right, go ahead, Cam. Get your hand up. What do you think?
Sine. So.
Good. He said sine. So we're going to do the sine of the angle. And that is because what was the opposite side? Good. X is the opposite side. And then we want to put that over the hypotenuse. And what's the hypotenuse? 15. Because this would have ended up being our right angle right here. So the side opposite of the right angle would have been that 15. You solve it the exact same way we just did that previous one. Multiply the 15 over. Throw that into your calculator. What's that give us?
11.8.
Okay, I might rely on you guys to take kind of a process to plug it into that beast of a calculator on the computer. And then this is, do I give you units here? This is now measured in feet. All right. All right, number 3. Let me make a little space here. All right, so as an airplane takes off at an angle of elevation of 21 degrees. So kind of understand, we have a flat surface that the airplane would be traveling on. Eventually, as the airplane is traveling, it's going to start to go into the air. And what you're told is that angle at which it's elevating into the air is a 21-degree angle. So here's our runway. The airplane's going up. It's going up at a degree measure of 21 degrees. Then, what this is asking for, now be careful with this, It says the plane travels 10 miles. So this is the plane traveling right here, correct? So we're not necessarily looking for the horizontal distance that it traveled. His hypotenuse distance, once we turn this into a right triangle, isn't this longer than the horizontal distance? So when you're told the plane traveled 10 miles during the initial ascent is his climb upwards. So that 10 miles goes right here. And then the question is, after it has traveled 10 miles during the ascent, at this angle, how high off the ground will he be? Well, if he's now here, after he's traveled 10 miles upwards at 21 degrees, the question is then asking, how high above the ground is he going to be? All right, so set that up. Hopefully now we're starting to kind of get a hang of this. All right, Vicky's plugging something in. So what are you plugging in, Vicky? What did you set up first? Good. She says the sine of 21 equals x over 10. We all agree with that? Good. Here's the angle we're concerned about. This is the opposite side. That's what we were looking for, so we'll call that our variable. And then here's our 90-degree angle. So the 10 is opposite of that. That's your hypotenuse. And at this point, you better be able to plug this in, because the same way as plugging the first two in. What'd you get, Vicki? And then that was miles. All right, so 3.58 miles above the ground. Okay. All right, now 4, a little different. Don't think these are any harder necessarily, but it says from a 60-foot observation tower on the coast, a Coast Guard officer sights a boat in trouble. So he is on the 60-foot observation tower, standing there looking down at a boat. So let's draw the observation tower here. So this is our tower. And then we have our guy standing up here. All right, so there he is. We know the tower is 60 feet. So we'll label that 60. He looks down in the water, so here's our water here. And he sees that a boat is in trouble, so we have a boat out there. So we'll say this is our boat. And then it says the angle of depression of the boat is 3 degrees. So what that means is, as he looks here towards this boat, remember what angle of depression is. Let me go back up to when we drew this in. The angle of depression is still formed with the horizontal and your downward angle. So the horizontal along with the downward angle. So if I have this guy standing up here, his horizontal would really be looking out straight across. So this is the horizontal. This is his downward angle. So the angle of depression is this guy right here. That is a 3-degree angle. All right, now notice, let me draw this in black. Our right triangle that we create in this figure, is that 3-degree angle even in the right triangle right now? No. So that's why we want to understand, if this is a horizontal line up here, and this is a horizontal line down here, aren't these then definitely going to be parallel lines? And if I know this is the angle of depression, question, you're going to give me this?
I was about to say this, the opposite side, that should be 3, it actually equals 90 on the other lines. So you go try to
If we wanted the angles, yeah. So if we wanted that angle, we could. But first, let's get to what Ahmed said. These are alternate interiors, so we ultimately then know that that angle is a 3-degree angle. Okay? Now, we don't necessarily need the other angle, but you certainly could find it. What we ultimately need for this question, how far is the boat from the shoreline? So here's our boat. We're going to assume the tower is right here on the shoreline. This is what we are trying to find. Set that equation up. try to solve that equation. The setup, hopefully we can get. It's still just a SOHCAHTOA idea. The steps to solve it are a little bit different. So see if we can then solve it once you have it set up. All right. Gavin, what did you set up? Good. So he said the tangent of 3 degrees, so the tangent, and that's the opposite side. The opposite of that, then he said, is 60. The adjacent side of that angle, the non-hypotenuse adjacent side, is your x. So we get this. This now does require a little bit different in terms of solving, but it's still old algebra ideas. So what we talked about when we did these, we don't ever want our variable in our denominator to solve an equation. So to get it out of the denominator, we could just multiply both sides by x, so that we just have 60 degrees on the right-hand side. Whatever I do to one side, I've got to do to the other. So I got to multiply that side by x. So if in the next step I have this, isn't x getting multiplied by the tangent of 3? So the way we undo multiplication is through division. So if I now divide by the tangent of 3, we now can divide by that trig function. Don't misinterpret this, what I said earlier. Earlier, if it was like the tangent of a equal 5/4, I can't divide by a blank old tangent. It has to be the tangent of something. We now have that. We're doing the tangent of 3. So that's why this one we can go ahead and divide that trig function over. And then it should be whatever 60 divided by the tangent of 3 is going to be. It's going to be a pretty big number. How far away is this guy? What do you think? 1,000. What? 144. Okay, and then that was feet. All right, so that's how far away we are. Okay. All right. I want to see. So we didn't give them any. Okay. Let's do one more. I want to make sure we do 10. Let's do one more. Make sure we're all feeling good about ourselves. Go to number 5. I think 5 is a nice one. So I'm not setting it up. I'm not drawing it. See if you can solve that. See if you can draw your own. Oh, that one's tricky too. Do this though. Just do this. And just say a person is standing 100. Just do that. So don't worry about the 6 feet. It's not worded very well. So don't worry about the 6 foot. The guy's just there. So see if you can sketch a picture, assign the location of the numbers and the variables, see if you can answer that question. hopefully this is what we set up. You have somebody standing over here. He is standing, so he's on the ground. He's 132 feet from the tower. So here's my tower. And then we knew from the person to the tower, 132. His angle of elevation to the top of the tower, so him looking up to the top of the tower, is 25. The question is, how tall is the tower? So that's where we should have assigned our variable here. And then now we determine, is it a sine, a cosine, or a tangent? Becca, what do you think? So if this is our angle, what are we dealing with here? Opposites, adjacents, or hypotenuse? Good. She said the opposite and the adjacent. So that's the whole little TOA option. So that is a tangent. So the tangent of our angle, the opposite side is the x, the adjacent side is 132. This is the one that we've solved a number of times today. Multiply that 132 over. All right, 61.55. Good. And then that is what? Feet. All right. All right, the next one I want to get to, go to number 9. A little trick. Actually, let's do 10 first. I want to do 9 and 10, but let's do 10 first because it's in line with what we've been doing, yet at the same time a little bit different. So it says an 18-foot tree cast a shadow of 25 feet. So first, see if you can draw that. See if we can process what that picture looks like. Have a vision in your head. See if you can do that. Beautiful tree. Beautiful sun. It's actually not bad. Happy with that. All right, should have an 18-foot tall tree, right? Casting a 25-foot shadow. Find the angle of elevation for the sun. So we have our tree. Here's the sun. It has to be over here, right? If our shadow I drew is over here, the sun has to be on the other side. So this is kind of where our right triangle comes in. And then if we just measured the straight up and down height of this tree, the question is asking you, or the angle of elevation to the sun. So this is what we are trying to find, our angle that we would be looking towards the sun from the end of the shadow. The shadow is 25 feet. The tree, we know, has a height of 18 feet. Solve that now. Here's why I wanted to make sure we do this one. So set that up and see if we can now solve this equation. All right. Let's see where we're at. So this is the first one. That's why I kind of jumped a little bit to make sure we see one before we check out for the day, where you don't know the angle. Every other problem we've done up until this point, we knew what this angle was. We still need to understand this is the angle that we're basing everything off of. So when I look at an 18, we'd hopefully see that's the opposite side. 25 is your adjacent side. So if that is our opposite and the adjacent, we would want to be using the t, which is your tangent. Every problem up until this point today, we actually knew what the degree measure was, and we would assign it there. Do we know what that is now? No, so that's your x. So that's what we're going to be setting inside of that tangent. So the tangent of that unknown angle has to equal 18 divided by the 25. Okay, follow that. Then the reason I want to see it too is, do we know how to solve this? Because a lot of us have not known how to solve this the last couple of days when I put these things on Canvas. So now solve that. And hopefully you've already done it, but see if we remember how we just did it at the beginning of class. I want to be able to do that. All right, like 30 seconds, Cam. All right, Cam, how do we solve that?
Mr. Cruz just reminded me that we can't divide the tangent like by itself without it having anything with it.
Good. So what Cam just said, if you heard at home, if I want to get rid of this tangent, I can't just divide a tangent unless I know the tangent of whatever we're looking for. So if we're going to get rid of that tangent, we can't do that through division. So how do we get rid of that? Good. So this is when you've got to do the second tangent, that little tangent to the -1 of that 18 over 25. Okay. What did that give you, Cam?
35.75.
0.75?
Yep.
And then that should be our degree measure for that angle. All right. You get that? Okay. All right. Now I'm undecided what I want to do. Yeah, let's hold off. I'll spare you some homework. I want to do some of the triangle ones. I want you to see number 9. That's one that I don't want you to try in the homework until you've seen it. So bring this back tomorrow. We'll do 9. We'll hammer some of the triangle ones out, and then we'll give you homework for the weekend. All right? So if you're home, you're free to go. If you want to look at that Canvas thing, you got a minute or two if you had any questions on them. But if not, we'll see you tomorrow.